Hello, in this sixth chapter we will continue seeing the different variables and to the previous chapter. In this chapter we will see three types of different variables: conversion to convert the format of a variable from one type to another. We will see the variable qualification and scope, to see where you can use some variables in function of where they are declared and options that we have in these variables. To end with, we will see some practical utilities to work with variables and data. First of all, we will see how it is converted a variable into a character. Basically, you have to enter the code char and set the name of the variable inside the parentheses. In order to transform the variable into a char, this process is the same that we use to transform a variable into a byte. And also it is exactly the same to transform to an integer variable with the sentence int. To transform a variable into a word, there are two different options. The first one is for transforming any value to the word type, adding directly the name of the variable in the parentheses. The other option is indicating the order number, high or low, of bytes that conform the word. On the other hand, for transforming a variable of float type, it is also sufficient to enter the name of the variable inside the parentheses, in the same way as we will do with the float variable, as we can see in the explanation of the Arduino web page. With what we have seen so far in this chapter and what we saw in the previous chapter, we can now start working knowing all the main possibilities that we are going to use in a project. Now we need to know what is the scope of these variables. The variables can be used for the entire program or can be used in a specific function. Everything will depend on where we declare this variable. So far, we have indicated that we declare the variables at the beginning of everything. When we do this, the variables can be used throughout the code. This means that we want to simplify a function, which can cause us some problem. For this reason, we can declare a variable directly within a function. As we see in the example here, a variable is declared at the top of the code and two variables inside the loop function. These two variables can be used inside of the function. So, in the case that we program different functions in our program, this one won't be visible. Another property that can be given to a variable is the property of static. This means that this variable is valid only when a particular function is running. As we see in the example inside the random walk integer, we define an integer with the name place preceded by the static text. This variable will be valid only when it executes the variable. We recommend you that you do the indicated example in the page in order to understand in a correct way this property. In fact, I recommend you this because all we are commenting during the course, as little by little we are increasing the material to take in consideration in order to do an industrial project with Arduino. The next property that can be defined to a variable is the volatile. This property has the feature that it is stored temporarily because it is loaded from RAM. A variable must be configured as volatile when its value is changed due to simultaneous execution thread. This with Arduino only happens when we use the interrupt entries. For this reason, we see in the sample code that the state variable is declared as volatile. As we see in the blink interruption, this variable simply changes states once when the routine is called. Therefore, you only have to take this type of function into account when using interrupt entries. A last property that we have is to know is the constant. A constant is a variable that once it is configured and declared, its value cannot be modified. This is very recommendable when we have to do math operations, for example, so we can avoid to modify the value of the constant in the sketch. To end the section of variables, we have to see two very practical utilities, such as sizeof, that helps us to know the number of bytes depending on the type of the variable. For example, if we do the sizeof of a long variable that has associated the number 125, the sizeof macro will return a 4, as a long variable is 4 bytes long. Or in the case of an array, it will return the number of bytes that has the array, as we can see in the example where basically it is executed the 4. sentence while it's printing all the characters of the array of characteristics of the variable meister. To finish with the variables, we can also store a variable in the flash memory available in the Arduino, instead of using the SRAM memory simply by using the progmem statement. I recommend you review the types of memory available on the Arduino boards to know when you should store a variable in a corresponding type of memory. In order to store the variable using the progmem statement, it is essential to declare the avr pgmspace.h library in the first lines of our program, before the setup. From here, there are different ways to proceed with the storage of variables. First of all, this procedure can be used to store a single variable, but it can also be used to store more amount of data as needed. It is also necessary to use two different procedures after storing the data inside the flash memory of Arduino board. The following message can be read and treated as the example code that looks like it is saved and transferred from progmem. Well, once we have seen all the type of data that we are going to use to carry out any project, let's see how these are written in the Arduino IDE, and what things need to keep in mind to use each of these variables. First of all, Arduino identifies uppercase and lowercase letters. So if we declare the push button variable in lowercase, in the push button variable with the uppercase V, we are actually declaring two totally different variables. By declaring a variable as integer, we can also assign the state low or high, since it would be equivalent to 0 for low and 1 for high. I recommend you, after writing a variable, add a comment using 2 consecutive bars, as done in C. To assign an Arduino pin to a variable, this variable is configured as const, so the value of this pin cannot be modified during the entire program code. When configuring digital signals as input or output, it is important to use the pin mode statement inside the setup function, defining, in this case, that is an output, we will write the text output in uppercase. To define different types of variables, we just have to write the code we have seen in chapter 5 and 6, as you see, where if we want to define an unsigned long, it is enough to write unsigned long followed by the name of the variable and assign it the value that we want this variable to have from the beginning. If we want to designate a constant, we simply have to write the text const followed by the type of variable, long, int, char, short, or the type that we want followed by the name that we are going to assign to the variable, and to give it a value, we will indicate it with the symbol equal. Procedure of the assigned value, and we finish all the sentence with semicolon. In the setup, we can also directly define the Arduino pins without having put any name to this. This I do not recommend, but I can be useful to practice. Another thing we have seen is that we can declare a variable directly within a function. In this case, this variable can only be read by the function where it is registered. Also, all the variables that we have declared before the setup can be seen by all the functions. To modify the value of the variable, as you can see, simply write the name of the variable followed by the same symbol and the new value of it, high or low, which as you can see automatically change color if we write the sentence correctly. But we can also assign the value of a variable depending on the state of an input using the digital read statement by indicating the pin number of the digital input, or we could also use the name of the variable associated with this pin. On the other hand, we also saw variables of the logical type which indicate the status true or false. This is what we interpret using the if statement, where we define a condition. In this case, let's state greater than 100. What? If this is true, the corresponding code is executed. In the event that we would like to take in action, in the event that the condition of the if statement were false, we used the else sentence. Well, once seen this, in the next chapter we will see how to perform different mathematical operations as well as different communication systems. So, from the next chapter the video will be combined. Theory on the one hand and cases of communications on the other. I'll wait for you on the next chapter.